Introduction of velocity and acceleration. Velocity is a vector quantity that describes the rate of change of an object's position with respect to time, including both speed and direction. In other words, velocity tells us how fast something is moving and in which direction. For example, Ali cycling starts from point A to point B, which are 150 meters apart. If Ali takes 10 seconds to travel this distance and he's traveled to the east, from this example, we can conclude that 150 meters is a distance and 10 seconds is a time taken for Ali cycling from A to B. Acceleration is a vector quantity that describes the rate of change of velocity of an object with respect to time. It indicates how quickly an object is speeding up or slowing down and in what direction. It has positive and negative. If the positive acceleration means an increase in velocity, while negative acceleration, or in other names, deceleration, mean decrease in velocity. For example, Ahmad starts cycling from rest 0 meter per second and the reach speed of 10 meters per second in 5 seconds. We can conclude that the final velocity, which is u, 10 meter per second, and the final velocity is 10 meter per second, and the time taken for Ahmad start cycling from start to final is 5 seconds. The formula for velocity is change of displacement divided by total time, and for acceleration is change of velocity divided by time taken.
Next, I will explain about the problem statement for this case study. The first one is
Hidayah is a cyclist. She spent her free time on weekend with her cyclist members. She was travel at a constant velocity of 6.5 meter per square westward and then speed up with a steady acceleration of 3 meter per square. Calculate the Hidayah speed after accelerating for 10 seconds.
From the question, we know A is 3 meter per second, U is 6.5 meter per second, and T is 10 seconds. And find the V. We can use a formula V minus U equal to 8E. Next, insert the information that has given from a question. So we get 36.5 meter per second. Next, for question 2, this is the problem statement for velocity and acceleration in motion graph.
Aliyah cycles a 400 meter race in a time of 85 seconds. In a model of this race, it is assumed that starting from the rest, she moves with a constant acceleration for 5 seconds. Reaching a speed of 5 meter per second, she maintains this speed for 60 seconds and then moves with a constant deceleration for 20 seconds, crossing the finishing line with a speed of v meter per second. First, sketch a speed time graph for the motion of Aliyah during the whole race. Next, find the distance run by Aliyah in the first 75 seconds of the race. Find the value of V and find the deceleration of Aliyah in the final 20 seconds for her race. Based on the question, this is the answer for the graph. Next, calculate the distance for first 75 seconds. The formula is distance equal to 1/2 times with 60 plus 65 and times with 5. So we get 312.5 meter. For question C, we need to calculate the V, which is the speed we use area of A, which is 1/2 times with 5 plus V times with 20. Distance represented by A is 400 minus 312.5, we get 87.5. After we get
this answer, insert back to the formula and we get V equal to 3.7 meter per second. Last equation is we need to find a deceleration. We use a formula A equal to V minus with U and divide by T. 3.75 minus 5 and divide by 20 and we get negative 0.0625 meter per second square. The deceleration is 0.0625 meter per second square.
From our discussion, we conclude that acceleration directly affects velocity, with change in velocity being proportional to time under constant acceleration. Applied mechanics help us understand and experiment with this concept. In cycling, acceleration is key whenever starting, speeding up, or changing direction. Frequent direction and speed change in sport highlight the crucial role of acceleration in performance.